All right, so here's what we got to do. Just really quickly here, guys. Got to just summarize as a review, okay, our rules for naming and writing formulas. Okay, whether I'm naming or writing the formula, what's the first thing I have to do when I see the name or formula of a compound? Right, I got to decide first, okay, ionic or molecular. All right, once I make that decision, okay, then I can start on the appropriate set of rules, okay, to get me either the right name or the right chemical formula. All right, special rules here if we're dealing with ionic compounds, let's say. If I want to make the name, all right, I'm given the formula and I want to make the name, what are some things I need to remember about ionic compounds? Julia? Okay, you're right. Sometimes I may have a polyatomic ion. Okay, in that case, what do I have to do? Okay, so find the metal, okay, and write it first, and then put in our non-metal or polyatomic ion, as the case may be. All right, so always remember, all right, metal first, okay, non-metal second. All right, or polyatomic ion, as the case may be. What if we run into those special metals? What were they called? Okay, so if we have multivalent metals, how do we figure out which Roman numeral to use? Right? Okay, so which part do I use, the metal or the non-metal, to help me figure out that charge? Right, use the non-metal. Okay, so for multivalent metals, okay, use the non-metals charge, okay, to find the Roman numeral. And we reviewed how to do that yesterday as well. All right, if I'm writing the formula for an ionic compound, what's essentially my only rule I have to remember? How do I get the numbers right? Drop and swap, okay? All right, so that's really quick and dirty summary, okay, of the ionic compounds. For the molecular compounds, all right, how do I know which one to write first? No, this is a molecular compound, so I don't have any metals. Right, whichever order it's given to me. All right, if I'm given the name in writing, let's say potassium difluoride, or sorry, phosphorus difluoride, then I would put the P first. Okay, because that's what came first in the name I was given. All right, same thing. If I'm given a formula, if I'm given, for example, let's say N2O3, I wouldn't put oxygen first in the name, would I? Right, I just do it in the order I'm given. How do I know either what numbers to put in the formula or what to write in the name? What do I use? I use the prefixes. Okay. So prefixes determine the numbers, okay, and vice versa, depending on which way you're going. All right, whether you're going from name to formula or from formula to name. Okay, you either use the numbers to determine the prefixes, or you use the prefixes to determine the numbers, right? And you're off. You don't have to drop and swap, because dropping and swapping won't do anything on a molecular compound. All right, ringing a bell for everybody? Okay, you have quite a few practice items there. I don't think it's going to take you very long to get them done, right? But what I want you to do today in class is to get as close to done as possible. I would imagine you guys will probably finish before class is over. If there are any that give you trouble, let me know. We'll go through them together. Here's the big thing though, guys. I looked around and I saw a lot of you had done these anyway, even though I told you not to. Okay. Make sure you check the key as you go. Okay. The key is on my website, and I'll just pull it up here, right, so that you can check it, and then I will read your announcements, because I forgot to do that too. Okay, so if you go into chemistry, down at the bottom, naming key 1, naming key 2, naming key 3, right? So these are for all the sheets that you have, okay, in front of you. Make sure that you don't do more than 4 or 5 at a time before you check the key. All right, because if you've done like a whole page and then you check the key and you realize you've been doing something wrong, how many times have you practiced it wrong? A lot, like 40 maybe on some of those sheets. Okay, and that's not good because now you've got a habit to break, and we don't want to get into that situation. So don't do too many at a time before you check the key to see how you're doing. Everybody follow? All right. Okay, don't know if anybody's noticed it yet. John noticed it. On this, on the naming compounds worksheet, there is a typo on number 23. It reads on your sheet K2N, but that is impossible because nitrogen has a charge of -3. There is no way you could only have 2 potassium there to balance it off. So there's a typo there. It's not going to change the name any, all right, but the formula is wrong. So we'll change that to K3N here. Okay, so you'll just have to change that one to K3N. Right, and then it doesn't change the name. If you named it potassium nitride, you were right. It's just you didn't have the right formula to get that name. All right, guys, just quick review here because I've had a few people come and ask about writing the formulas for these ones down here on the final formula review sheet on the bottom, where it says you'll need your table of polyatomic ions. Just a reminder, doing the swap and drop isn't any different when you're using a table, your polyatomic ions. It's just sometimes you have to use brackets. All right. So if we're looking at, for example, number 3 here with iron 3 nitrate, okay, we still do the same thing we always do. We write iron. It's in this case a +2 because the Roman numeral tells us the charge, and then nitrate is NO3, and it's a -1 charge. So I drop and swap, same as before. I take the 1, I put it here, but we don't write ones. Okay. Then I put brackets around this, take the 2, and put it down here outside of the brackets. Okay, is that ringing a bell? Right, so it's just like the swap and drop with regular elements, it's just sometimes you have to put a bracket. Okay. Guys, there's a mistake on the key. Okay, for this worksheet here, okay, the predicting formula for compounds, there's a mistake on the key. All right, I think I actually have it right on the file for the smartboard, but I don't have it right on my website, okay, because I've made the correction. That formula right there is incorrect. Okay, aluminum nitride should be Al, since that's a 3 plus, and nitrogen is a minus 3. They're both 3's, so they cancel each other out. It's ALN. Right, so if you were checking your work on that one, you might want to, okay, just make sure you realize the key is definitely wrong on that one. All right, guys, just another mistake here. I'll have to redo this key because I've changed number 7 down here. Okay, it's francium glutamate on my key, but glutamate isn't on your new table of polyatomic ions. So I had to change your worksheet, but I forgot to change the key. On your worksheet, that says francium phosphate. All right, francium phosphate is Fr3PO4. All right, so if you've gotten to that one and you weren't sure what to write for that, that's what you write for that, Fr3PO4. Okay, guys, another mistake here. 53 says PBr4. How many is penta? Yeah. Should take my time and not do these when it's 11:30 or 12 o'clock at night. Okay, so PBr5. All right, a situation that you might encounter with ionic compounds, okay, could be something like this. Let's say I was given manganese 4 sulfide as a name. All right, when I have a name that has a Roman numeral in it, what is the Roman numeral telling me? Right, it's telling me the charge on manganese. It's not telling me there are 4 manganese atoms. It's telling me the charge on each one of them, however many there will be, is 4. All right, so I would start out using my regular rules here. Mn is 4 plus, because that's what the Roman numeral tells me. Sulfide is minus 2. Now what do? Drop and swap. Okay, same as you would for any other ionic compound. So I take the 2, I put it here. I take the 4, and I put it here. Should I leave it that way? No. All right. Ionic compounds only, not molecular, are like fractions. You have to reduce them down to their lowest terms. Right? You wouldn't leave a fraction written as 2 over 4. Right? You'd reduce it to 1 over 2. All right? So the correct formula for manganese 4 sulfide is actually MnS2. So anytime you have an ionic compound and the numbers can be reduced, do so. Okay, reduce them. What if on a molecular compound you have 2 numbers that would be reduced? Do you reduce them then? No, because the prefix has told you it's 2 of this and 4 of that, or 3 of this and 6 of that. The prefix has told you that's how many there are. That's how many there are. Right? The only reason we can reduce them in an ionic compound is because we're balancing charges, and it's probably that form, the lowest form anyway. All right, does that make sense? You're going to run into that once or twice. Now, we found a couple of mistakes on my key, a couple of mistakes and a couple of things that I've changed since. Okay, so I just want to run over those really quickly. Okay, I have all the keys open here, right, to the worksheets that I gave you yesterday, so you can come up and check as you go. All right, one of the first ones, and now of course I won't be able to find them. Was not on that page. Okay, so number 7 here on the page that is called write the formulas for the following compounds. Okay, so it looks like this one here. If you can just go to that one. Right. It says on my key here francium glutamate and then omit. The reason I have that on the key is because you don't have glutamate on your new table of polyatomic ions. So I changed your sheet but forgot to change the key. Your sheet says francium phosphate. All right. So when you're doing that one, francium phosphate should come out to Fr3PO4. Right, so when you come here, you'll be able to see that one on the key. Right, but just change yours says francium phosphate. Don't get confused when you look at the key here. And there's the other one. Aluminum nitride, number 29 here. So if you go to okay, this sheet here, predicting formula for compounds, right, and you look at number 29. Number 29 is also wrong, okay, on the key here, right? That should be ALN, right? Not AL2N3. That's not right. Okay. So there were a couple of other ones, but I don't remember what they were. If you encounter them, just let me know and I'll go over them again. But there were a couple of mistakes that we found in this morning's class. Okay. All right, so let's have a look here, guys, at number 11, nickel 3 phosphate. All right, so we treat it same as we would any other ionic compound. What does the 3 tell us? The Roman numeral 3. Right, that nickel is 3 plus in this situation. So we have Ni 3 plus, and then we have phosphate, PO4, which on your chart is the only triply charged, okay, polyatomic ion. All right. If this is 3 plus and this is 3 minus, does this already add up to 0? Okay, I mean, if I swap and drop, I can have 3 and 3, but I'd just reduce it to 1 and 1 anyway, wouldn't I? All right, so I just simply go NiPO4, and I'm finished. All right, the goal here is always to make our compounds equal out to 0. Right, that one already did, so we didn't have to do anything else. Any others? Okay. Okay, guys, just one I want to go over here because this one has come up pretty much every class today. All right, number 11 on your sheet there, naming compounds. Probably the one you're doing, maybe not the one you're doing first, but okay, it's the one that says naming compounds at the top. Okay, and it's number 11, and it's got nitrogen, 4 hydrogens, and 1 chlorine. And people are having trouble figuring out what this stuff is called, okay, because it's got more than 2 elements in it. If a compound has more than 2 elements in it, then there's a polyatomic ion in it. All right, so what we have to do is look at our table of polyatomic ions. Now, it just so happens this one is a little extra confusing because it contains the only polyatomic ion that is positive and acts like a metal. Okay, and that is this stuff here, NH4. Okay, NH4 is on your table of polyatomic ions on the very top left. Okay, and it's called ammonium. Okay, it's one of the ions that's used in fertilizer to provide nitrogen to plants. Okay, ammonium, and then this is chlorine, so it's ammonium chloride. Okay, just like any other ionic compound. Okay, name it the same. Okay, you get another chance at it down here in number 13. All right, does that make sense?